blue part and the helmet together, I'm going to do this with a fillet radius. So let me set this up first, and I'll say preview. Now if we were to flatten out both of these surfaces, parametrically they're both very, very large, so we have a lot of lines in both the surfaces, and there's probably over 100 cross-sections in the blue surface alone. So what PashShape's doing now is it's working out the curve of intersection between two fairly complex surfaces. And in this case we should see two tracks. We get a fillet on the inside and a fillet on the outside. So PashShape just takes a couple of seconds to calculate these two tracks. Okay, now I've hit this preview mode, so it will show us both tracks at the same time, and then that will allow me to create both the fillets in one operation and also trim the helmet to that kind of bead surface that we've created, so the whole thing remains as one closed volume. Okay. If you're going to use these for rapid prototyping, we really need a complete closed volume. You don't want any overlaps or any intersections on the resulting model. Okay. I should have probably dropped the tolerance down here again. When we're doing operations like this in PashShape, it's creating a new fillet surface to within a tolerance, a user-defined tolerance. So the tighter the tolerance, the more time it takes to calculate all the tracks. So I've probably left the tolerance a little bit high for this. It's taking slightly long. Okay. So let me calculate. While this is going, has anybody got any questions at all so far? Anything I'll show you?
And when you actually deleted the bits you don't want,
yes.
Would that be standard practice, or would you keep them in case you want to go back and modify?
You would probably keep them, in all honesty. I just tend to delete things so they don't get in the way. So yeah, you would probably keep them. Okay, and just on that note, PashShape's got 1,000 levels. It's very rare they ever get used, but you've got control over what's displayed and what's hidden very simply in the software. Okay, so here we've got that's why it took so long. I didn't choose that option very well. I'm not certain this fillet will work because I didn't choose the surface creation option too well. But you can see there we've got the two tracks where the fillet will fit, and let's see if this is going to work. So I'm going to say fillet all of this together, and I'll say go. That's why that took so long. I didn't actually choose the option to smooth out the corners and that surface creation, so I'll see what happens here. Okay, that has worked. You would probably make that slightly smoother than that is. Okay, but that fillet's worked, so that's actually created two fillets, one on the inside, one on the outside, and it's trimmed the whole model back, so we've still got a closed volume in there. Okay, so just a very simple custom add-on, custom design add-on there, just that kind of bead. Now to introduce the tri-grid element of this, I'm just going to drag in an STL file of a skull. Now this was actually created in ArtCam. If I draw that on its own, I'll just find it, I'll spin this across. ArtCam is another software package written by Delcam. It's very good at making high detail, low height, we call it a relief type data. So something like this. This started off life as a 3D skull, a full 3D skull. And I squashed that down, smoothed it out, added, returned detail to the model, so I put the teeth back in, made the eyes slightly more deep and made the nose slightly deep. And that kind of work can be done literally in seconds in ArtCam. It's very, very fast at doing this high detail, low relief type work. Okay, now this is basically an STL model, a triangle model created on a flat base. We want to wrap this onto our helmet design. Okay, so I'm going to pick the surfaces that this is going to go onto. And I'm going to, again, walk through a wizard which is very similar to the wizard that we used for wrapping the curve. So identify the triangle model, we create a coordinate system. Again, we get the opportunity to minimise the distortion with the wrap map. PowerShape again shows me an image representation of our STL model, which gives us the chance to change the location, change the size, to spin this around if we need to. When I've got it in the right place, I can say I want you to trim that, because again we want a closed volume, and I'll say OK. So PashShape now wraps that triangle model onto the surfaces, and that's the result we get. Okay, so a bit of a Harley style design. If I draw everything together, I've still got the other triangles in there, but this is now a mixture of surfaces, solids and triangles all combined to make a custom product, a custom lining and a custom outer for the helmet. Okay, so that's the end of that little presentation. So, are there any other questions?
How hard is it for user scripting functionality there, so that I can take a library and just say batch produce all these as a user?
It's behind PowerShape. There is a language, a macro language, and we have hooks for programming languages as well. So you can actually capture the creation commands and build your own VB or C applications that hook into the software. So that we do that quite a lot. So,
is that user accessible, or is that something?
Yeah, it's user accessible. Obviously, you need to understand VB6, VB.NET, C++, but actually capturing the commands in PowerShape is quite simple, and there is full documentation of all the macro language in the software. So we have a lot of users that do that for themselves. Any other questions at all? Yeah.
When you've done the conformal intersection, how were you producing the actual parts themselves?
We've got a customer that does this. In India, it's a company called Vega, and I did ask somebody that question, and I've forgotten what they said. I think they actually machine a soft material to make the mail of the inside of the helmet, and then they vacuum form over it, I believe. I'm not actually certain, I forgot. I did ask that question, and I forgot what the answer was. But I know there was some machining involved and vacuum forming, so...
Do you have any idea of what the difference in cost would be between, say, producing the one you've just done there and buying one off the shelf, so to speak?
I don't. It's obviously a lot more expensive because everyone's unique and there's labour costs involved. I mean, the company that we have doing this with our software is called Vega, and they're based in India. So I guess their production costs are lower, so they actually sell helmets around the world. You see them advertising in motorcycle magazines. But I don't know actually. Obviously, it would cost a lot more. Same as shoes. We do work with custom shoes, and they're obviously a lot more expensive than walking into your average Clark shop and buying a pair off the shelf. So at least 5 times more, I would imagine.
Pricing on the text this afternoon. It's clear there is a higher cost, and it's all about what customers are prepared to pay. Customised products, it's a completely different playing field than standard products. So you're straight from pricing when see what the customer will start to consider reasonable for the